Okay, so this is going to be the fourth question of the 2024 AP Calc AB and BC free response questions. Alright, so we have a graph here. So the graph of the differential function f shown for negative 6 to 7 has horizontal tangent at x equals negative 2. Yep, kind of see that there. Okay, and is linear for 0 to 7. So 0 to 7, this is a linear function. Not sure if it matters, but I mean, let me I'm just going to do it all anyway. So this point right here, so this right here is at 0, is at 4, 0 right there. So 1, 2, 3, 4. This has a, so y is equal to negative 1 half x plus 2. So that's what that part of the function is. Okay. Um. Okay. Let R be the region in the second quadrant bounded by the graph of f, the vertical line. So this region right here is bounded above. Let R be the region in the second quadrant bounded by the graph of f, the vertical line at x equals negative 6, the x-axis and the y-axis, and this has an area of 12. Okay. So the function g is defined here. I'm not sure if it will matter, but sometimes you might even just get a point. Sometimes I've seen in AP questions where it might just be worth a point anywhere in any of the problem 4, where you can state like g prime is equal to f of x. I bet that will come up later. In any case, so okay, this doesn't seem too bad. So we want to find g of negative 6. So good thing that's defined for us right here. That would be the integral from 0 to negative 6 of f of t dt. I'm going to reverse those bounds, so that's going to be equal to negative integral from negative 6 to 0 of f of t dt. So let's go ahead. This will be equal to negative because I reversed my bounds, my limits of integration, and then let's go ahead and find our integral from negative 6 to 0. So from negative 6 to 0, oh, there you go, it's 12, it's given to us. So this is going to be equal to negative 12. That's g of negative 6. Okay, and then we have g of 4. So g of 4 would be the integral from 0 to 4 of f of t dt. Okay, that's simply asking for the area from 0 to 4. So from underneath the curve. So from 0 to 4, we just have this, since this is linear, this is just a rectangle. So our base is 4, half that's 2 times by 2. So that would be equal to 4. That's just area of a triangle. Okay, and then we have g of 6, which would be the integral from 0 to 6 of f of t dt. So that's going to be the area under the curve from 0 to 6. So from 0 to 6. Well, I know that this right here was 4, right? And so I can start with that. I can say 4. Now, from 4, we're only going 6. So only going to 6. So from here to here, the area underneath that would be, so half this base right here is a triangle again, so that would be, half of that would be 1 times by 1. So this would be negative 1 because it's underneath the curve, or between, underneath the x-axis. So 4 minus 1, that's going to be equal to 3. Okay. Alright. For part B. The graph of the differential function f shown from negative 6 to 7. Sorry, this is just the question. So for the function g defined in part A, find all values of x in the interval from 0 to 6 at which the graph of g has a critical point. Okay, so g of x, let me just write that down, was the integral from 0 to x of f of t dt. So the function g defined in part A, find all values in the interval from 0 to 6 at which g has a critical point. And a critical point would be when g prime of x is equal to 0. Now, g prime of x would be equal to so that would be equal to dx of the integral from 0 to x of f of t dt. So I'm basically just saying this right here. If I'm taking the derivative of this, I'm also taking the derivative of this. By the fundamental theorem of calculus right here, we'll just say that g prime of x is equal to f of x, which is what I was kind of saying earlier. And when this is equal to 0, so I just really need to use the graph right here. So when does g prime of x, which is equal to f of x, equal 0? So that's going to, since this right here is our graph of f of x, it only equals 0 at x equals 4. So at x equals 4. I think that should be good. What is my reasoning? Give you a reason for your answer. G prime of x is equal to f of x is equal to 0 at x equals 4. I think this should be enough for my answer. Enough for my reasoning anyways, and this is my answer right there. So I think that should cut it. Alright. C, the function h is defined by, given there, find the values of h of 6, h prime of 6, and h double prime of 6. Alright, so this sounds kind of similar to A, but so h of 6. First of all, yeah, h of 6. That would be equal to the integral from negative 6 to 6 of f prime of t dt. So essentially, again, I can use the fundamental theorem of calculus right here. I'm finding the area under the curve of a derivative right here, so that would just be equal to f of 6 minus f of negative 6. Again, it's basically just saying here that if you look up any theorem of the fundamental theorem of calculus, if you look it up, it's f of b minus f of a. That's what this is saying right here. Okay, so then in that case right there, f of 6, let's look at our graph right here. So f of 6 is negative 1, that's given to us there. So negative 1 minus f f of negative 6, so f of negative 6 is 1 half right here. So negative 1 minus 1 half is going to be negative 3 halves, or I guess you could say negative 1.5. Okay, I think that sounds right. Let's see, h prime of 6. Okay, first of all, let me define h prime of x. Okay, so h prime of x would be the derivative of this right here. So dx of the integral from negative 6 to x times by f prime of t dt, which would be equal to dx of, it would just be f of x minus f of negative 6. So I'm kind of using the same thing that I did here. This would be equal to f of 6 minus f of negative 6. Provided that I just leave this as x, this would be equal to that right there. I haven't taken the derivative of it yet, but if I do take the derivative now, so the derivative of f of x would just be f prime of x, and the derivative of this right here, well, since this is a constant and I take the derivative of a constant, it would just be 0. So I know that, so from doing that right there, I know that h prime of x is equal to f prime of x. I was probably a bit explicit there, but in any case, so if I want to find h prime of 6, that's going to be equal to f prime of 6, and f prime of 6 would be, so if I look right here, the slope at this point right here, and the slope at 6 right here of our function is negative 1 half. So that's equal to negative 1 half. Okay, and then I want h double prime of 6, I'm first going to define h double prime of x, because here, since h prime of x is equal to f prime of x, h double prime of x will be equal to f double prime of x as well. So if I take the derivative of that and that, so h double prime of 6 should be equal to f double prime of 6, and well, since f prime right here is if f prime of 6 is 1/2 the second derivative, so the second derivative at this point will just be 0, because the first derivative is a constant and the second derivative would then make it 0. So this right here would be equal to 0 right there. Okay, a lot of work for that one, but I think we covered everything. Okay, that's question 4.